Emergent Physics, a Grand Unifying Theory through Emergence. For centuries, physicists have sought a unified theory, a single framework that explains both the quantum and classical worlds. Einstein's relativity describes gravity and large-scale cosmic structures, while quantum mechanics governs the smallest known interactions. Yet, these two pillars refuse to reconcile, leaving a gap in our understanding of reality. But what if we are looking at this problem the wrong way? What if emergence itself is the key to unification? The divide, quantum versus classical. The fundamental issue in physics is that quantum mechanics and classical physics operate under different rules. Quantum realm, superposition, entanglement, uncertainty, and wave-particle duality define microscopic behavior. Classical realm, objects have definite positions, follow deterministic laws, and behave in a predictable manner. Bridging these two realms requires an explanation for how the uncertain, probabilistic quantum world transitions into the stable, deterministic classical world. This is where emergence becomes essential. Emergence as the missing link. Emergent systems arise when simple interactions produce complex, higher-order behavior that cannot be predicted by their individual components. We see this in thermodynamics, how temperature and pressure emerge from molecular motion. Life, how consciousness emerges from neural activity. Social systems, how civilizations arise from simple human interactions. Could physics itself be emergent? Rather than looking for a direct equation that links the quantum and classical worlds, we could recognize classical reality as an emergent phenomenon of quantum interactions. 1. Macroscopic determinism as emergent stability. Quantum fluctuations are chaotic at small scales. When enough interactions occur, they average out into predictable classical behavior. Example: a single atom behaves quantum mechanically, but a rock composed of trillions of atoms follows Newtonian physics. 2. Gravity as an emergent force. Some physicists already propose that gravity might be emergent, arising from the statistical behavior of entangled particles, like in Eric Verlin's theory. If gravity emerges from quantum entanglement, then space and time themselves may not be fundamental, but rather emergent properties. 3. Quantum decoherence and the classical world. When quantum systems interact with their environment, they lose their superposition and collapse into one classical outcome. This isn't just an interpretation. It might be the mechanism by which classical reality emerges from the quantum field. A new perspective. The universe as an emergent system. If emergence is the fundamental process that governs physics, then reality itself might be structured in layers. 1. Quantum fluctuations, the raw information of existence. 2. Wave function collapse, decoherence, the transition from probability to tangible existence. 3. Classical reality, the emergent stability from quantum chaos. 4. Cosmic evolution, galaxies, stars, and planetary systems emerging from fundamental forces. 5. Life and consciousness, a new emergent layer forming atop physical processes. Rather than a single equation, unification might require understanding the principles of emergent physics, how complexity builds from simplicity. What this means for science. 1. We should stop searching for a single equation of everything. Instead, we should study emergent principles and how nature transitions between different levels of reality. 2. Quantum gravity research should shift toward emergence. If space-time itself is emergent, then we should be looking at how quantum information organizes into classical geometry. 3. This may explain the fine-tuning of the universe. If fundamental laws emerge through self-organizing principles, then the universe may be tuning itself dynamically rather than being set by an external force. The Grand Unification of Physics through Emergence. Unification may not come from finding a way to force quantum mechanics and relativity to fit together. Instead, it may come from recognizing that the classical world emerges from the quantum one. If emergent physics becomes the foundation of our understanding, we may finally see reality not as a set of fixed, rigid laws, but as an evolving system of interdependent relationships, one that gives rise to the universe, life, and intelligence itself. Final thought. Instead of asking, what is the fundamental law of everything, we should ask, how does everything emerge? The answer to that question may hold the key to unifying physics. Wendell, President of Australia. WendellsDiary.com